My name is Eric Lopez. Today I'll be presenting structural design and mechanical parts for the 3DOP team for our senior project 2. First I want to talk about the tools and resources that I use for my part of the project. The first tool, very important, Tinkercad. This is a free software online that allows you to model any 3D object. Then Cura, this is powered by Ultimaker, and this is a tool that I use to check the properties of my 3D model before actually sending it to print. The properties such as density, resolution, and the support material that it needed, if any. Then the caliper and basic geometry throughout the model design. Caliper just to give me those millimetric measurements, really exact that I needed, and allow geometry to calculate the angles and the geometric shapes that I was going to use. Some of the key resources for this part of the project first was the Thingiverse website. This is an open source website with a lot of 3D models that I use as reference. The Ultimaker 2 with PLA filament. This is the printer that I use for most, if not all, of the 3D printed parts. Academic Technologies was one of the main sponsors for this specific part of the project. I also want to talk really briefly about the design process and implementation. The machine requirements, that was the first step. I referred back to the requirements of the machine and identified what the machine needed to do. Then I moved to the research, to look for existing designs or models. Then if it was a good design that I just needed to modify, I would make the adjustments, redesigning it, do the measurements. Then I'll follow to print the prototype and test it out. Then after testing the prototype, I will have to redesign, if needed, and print it again till the module, the 3D printed part, was successfully completed. I'll go over the structural modules that I worked on for the past 2 semesters. First, the corner blocks, then the XY motor pulley, the Z-axis mechanism, lifting the machine, its platform, Bowden Extrusion, extruder, mill, and laser, which are in progress so far. I'll go into detail for each of these in the following slides. The first 2 modules or mechanisms that I want to present are the corner block and the XY motor pulley. The original design was printed by Alejandro. It's the white figure that you see on the screen. But then we realized that we needed to make some changes to that. And this is the mechanism that supports 6 metal rods for the X and Y movement. And it also holds timing belts. And the alignment is accomplished by linear bearings. This is a picture of the final model or mechanism already assembled. As you can see, the smooth rods are being held by some metallic screws and also the timing belts. The next mechanism I want to introduce is the Z-axis. This consists of 2 smooth rods to achieve alignment and stability, and 1 threaded rod that's attached to the centerpiece that's going to allow the movement up and down with the rotation of the stepper motor. Here's a picture of the Z-axis already assembled, and as you can see, the stepper motor is here at the top. This is going to allow the movement of the threaded rod and the smooth rods to be aligned to achieve the movement up and down for the machine. The next structures that I want to present are lifting the machine and the platform. So since this is meant to be a do-it-yourself project, we tried to get the less expensive materials. We went to Home Depot and bought some PVC tubes. This will allow us to lift the machine about a foot above the platform, and also add for additional diagonal tubes to achieve better support. One of the last mechanisms that I worked on is the Bowden Extrusion, and this is composed of 3 different parts. The first one is this red piece that it's attached to the structure and also holds the stepper motor. The second one is this black piece, which was taken from a MakerBot, and that's the mechanism that rotates in order to pull the filament from the stool. This last part is the orange one, and that would only hold the filament in place right next to the machine. The last 3D printed part is the extruder, mill, and laser. As you can see in the picture, The mill has been printed and tested, and now we're working on the other two. That concludes my part of the presentation. Thank you so much for listening to me.